Hello. So I'm Ringo, I work for Pulumi, and today I'm gonna tell you all about Pulumi next to Terraform, which probably everyone knows in this room. So first of all, always like to start off with, who has heard of Pulumi before? Oh, I'm positively surprised. And who has worked with Pulumi already? Nice. All right. So first, a bit of an introduction. We use Pulumi infrastructure as code with programming languages, which means that you can program your cloud with your language in your way. So that means on the upper left, you see all our supported programming languages in which you can write infrastructure code. Yeah. And that means in the build part, you can use any of your favorite toolings along with it. Yeah. So whether it's IDEs, additional tools like TSLint, Mocha, test frameworks, package registries, it's up to you. Second is the deploy part where, yeah, you have to deploy something. So where do you do it? At the top, you see the major cloud providers and tools, and then you have a whole slew of additional providers in different categories. Once you have all your code, yeah, how do you manage that? Well, typically in Git repositories, and there you see the obvious ones, GitHub, Bitbucket. You have the CI/CD pipelines to deliver all these deployments. And of course, security, not to be forgotten, like Okta, SAML authentication, and alike. If you start off with multi-cloud infrastructure as code, because that's where it usually boils down to, not only with Pulumi, but as well with Terraform, is you are not typically sticking to your own cloud provider. You mix in a number of different additional tools. Yeah, and that's where, of course, everything you saw of of providers in general, yeah, because we also use that concept of providers, that gives you the interface towards all these technologies. If you look at Pulumi's core features, it's the top part, and then, of course, similar to that state backend, that state management that you heard Andre talk about, we have the same setup. Yeah, you can store your state locally, you can store it in cloud storage, or you can leverage our paid offering, our Pulumi cloud. Yeah. So the first three are definitely in the open source product. Yeah. The fourth one is something we will have to improve still on the open source one, but is available on our hosted offering. And then all the rest you see, no, not all the rest, except for Automation API. All the rest is from our hosted offering. Automation API, what is that? Well, typically we also believe that with code you need to integrate, you need to have the ability to integrate everything. So what does the Automation API allow you? Well, to embed all of Pulumi and setting up infrastructures in a bigger automation you want to define, whether that be a workflow engine or a custom REST server, for example, with a REST API call that then using Pulumi sets up an infrastructure. That's all up to you. Now, what is the high-level view of and the high-level architecture of Pulumi? So quite similar to Terraform, with the only exception is that we carved out the language separate from the engine. We have a declarative engine similar to Terraform, yeah, but the language host is our ability then to support all these different languages. All the lines you see between them, except the state, so but towards providers and between engine and language host, that's also with the gRPC protocol, although different from the Terraform one. So here you see how a normal setup behaves. You run Pulumi up, similar, which is the counterpart of Terraform apply. And at that moment, Pulumi will save your state of what it has set up based on your desired infrastructure. So once you have your code, of course, you want maybe to set up multiple environments for that. So if you look at a total Pulumi project, well, then it starts off with your sources, and that's what we call the program, where you define resources, and you might even take an output property from one resource, pass it in as an input to somewhere else. So, but that's your intended, your desired infrastructure. Yeah. Then you can have one or more stacks, which really is the state stored with an instance of that full program setup, which might be, for example, a dev QA and a production environment corresponding to running your program. So typical and probably not much different from what you used to with Terraform, although just a bit different naming. Let me show you already a small example. And okay, crank up my, is this readable? Yep, all right. So I have prepared some code, and this is actually the smallest possible Pulumi program. This one is using TypeScript as the language I'm showing. So I have regular TypeScript libraries I'm importing, and then I'm using just a constructor on the bucket class. I'm setting it to public read, and I'm taking afterwards the ID of that bucket, and I'm exporting that in my Pulumi program under the bucket name. Okay, let me run Pulumi up. There's one piece in my output. So these yellow warnings, ignore that. I'm testing myself in integration with 1Password, and it comes from that integration. So I don't have a stack yet. Yeah, so I'm gonna create one. And yeah, of course, I'm using our own Pulumi Cloud backend. So that means I'm using an organization name, and I'm using a certain name for my stack at the moment. We have within the company a habit of just using our own name to see who owns the stack on the platform. No, sorry. So the bucket will be created, and similar to a Terraform plan, this is our preview. Yeah, and I can now say, okay, I want to see first some more details of what will be set up. So although I gave the bucket the name my bucket, you see that as input, there's something behind it. Yeah, this is already one difference between Terraform and Pulumi. Yeah, we use a mechanism called auto naming. We always append that suffix, which then doesn't, which means that you don't have to do it by, for example, appending the name of the stack to it, because that could lead to a conflict on your cloud provider, because these differences, these resources, typically for things which only have a flat namespace, could be otherwise conflicting. So that's how we already change and make it auto-naming. The auto-naming part is also important for us internally, and not only for us internally, but also for you on how in certain cases we need to replace a resource which can't be updated in place. There are resources on Amazon, for example, if you change a certain property, well, a totally new resource will be created. That means with this suffix in hand, we can already create a new version, rewire any dependencies from the old to the new before we delete the new one. And this is definitely in the context of zero downtime deployments is actually a big thing. Yeah. So if you're working with Pulumi, please leave the auto naming in place. Don't override it by setting your own name, because then, because you can disable the auto naming, but at that moment it would, let's say, create more havoc in a way afterwards for you than it is benefit. I'm not going to apply it yet, because there's one thing. I have created that stack, but for my AWS, I didn't set the region. Yeah. So I'm gonna set the region, and I'm gonna use our stack configuration mechanism for that. So these are the input values for that specific stack if you run it. So for my stack named Ringo, I'm gonna create and set the region of my AWS provider to EU West 1. I need to select the stack. If you noticed, this file on the left was added now. And if we open that, you see that the stack configuration is saved here. Yeah. One of the things that you can add and that Pulumi has is integrated secrets management. Yeah. So secrets management means that if you set, for example, another configuration variable, for example, I'm gonna my secret, and I'm gonna really mark it as secret. I'm not passing any value because I don't want that value to end up in my shell history. Pulumi will ask me for what the value is. And it will encrypt it and put the encrypted version in the stack configuration. Yeah? So this file is always safe to commit to Git because you have the encrypted version here. Now, where is the encryption key? When using our Pulumi cloud, per stack, you already have a pre-made key. But you can integrate with AWS KMS, with Azure Key Vault, HashiCorp Vault, and even and that way manage the encryption key yourself. Yeah? So if you don't trust us in a way on our platform, you can still configure the key, the encryption key yourself, and that's different from where you store your state. Yeah? So it could be that you would still rely on our Pulumi cloud, but you're still free to use your own encryption provider. Yeah? And if you have that, well, that means that also the encryption provider then will end up in your configuration file, in your project descriptor here. So this is now actually fully configured. I created my stack configuration. And given I had and I'm going to open it again. Given I set the AWS namespace, yeah, this is also the namespace that the Pulumi AWS provider will read its own configuration from by default without having to specify any other code. Yeah. So I'm going to run now, skip the preview and apply it immediately. Let's hope my AWS credentials are still valid. Nope. All right, let's retry. Maybe in the meantime, I should also log in on the portal. Nope. Okay, let me comment out this for a minute because I actually need this for the second part of the talk. Yeah, indeed. Okay, so the bucket is created, and in this case, the name that now actually is used as the stack output is indeed the real ID, the real name of the bucket. Showing this on our portal, so I set up the simple Ringo stack. So here you see indeed the stack output and also the configuration I put in. This one is encrypted, as you see, and it's not only encrypted in the config, but once I use it in my program and I even start computing and mix in a secret with some non-secret text, all derived values are tracked by Pulumi as remaining secret. Yeah? So it could be that you create some key or an SSL certificate and you compute that to make a full kube config, for example. Well, your whole kube config will in the end be managed as a secret, will never be clear text, neither in state or in config, never. Yeah. So to give you an idea, now you see that there are 3 resources created, although I only gave 1. What are these other 2? Well, the stack itself is also a resource, and that's because we map that to the lifecycle. And the stack is responsible for creating the default providers that you're using in your program. Yeah. So it's the stack somewhere in the implementation of the stack that will scan, okay, I received requests to set up these, and these resources. Well, let me set up the provider for that. Yeah. And because they initialize the provider, then the provider reads its config, and only then the resources are created. Similar to Terraform, these are these separate processes which talk via gRPC. So it's not in your language host that the resources are created. The resources are just sending a request. Please make sure that this resource in the end exists. Yeah, every time. Yeah? Although you see a new constructor call, that's just your way of writing, please Pulumi engine, make sure that after running Pulumi, the resource is there. If it was already there from a previous run, well, the engine will compare that to the state and say, it's already there, so I don't have to do anything. Yeah. So this is the most simple program I can give you. Now, I don't think you all came here to say, yeah, to see just a bucket being created. Now, what is the intrinsic difference between Pulumi and Terraform? Well, one of the things, and I'm gonna switch back for a minute to the slides. So what about a bigger real use case? I'm gonna come back first and tell you first a bit about components. Yeah? So in components, given we are multi-language, you can write components in any of our supported languages. Now, there's a bit of a difference where you start. You can write, for example, here in TypeScript, a component resource. You give it a typical TypeScript constructor, and this part, the type, it's a 3-part type you give. This is core to how Pulumi works. The first part is the namespace. So for example, for every AWS resource, this part is AWS. Or if you use our native provider, which works against the Cloud Control API, it's AWS-native. Yeah? Then you have a module, and then you have the resource type. So in this case, I'm creating a component, and I'm sort of making an abstraction of a whole network setup. Yeah? Within it, I'm creating the normal AWS VPC and the subnet. So where is this code running if I have that in my normal Pulumi program? Well, that runs in the language host. So this is then a single language component. Now, we also have the ability to write your component once in one language, also make a binary out of it, like you heard Andre talk about provider development, and then generate all the specific language SDKs for all the other languages. Because once you have that separate binary as a provider, because coming back to the architecture, so I talked about the providers. Well, we use the provider model to make sure that we can also offer you the ability to publish components, but still have them consumed from any of our supported languages while you only have to implement them once. The big difference between that single language component and the multi-language component is you only have to provide a schema file, sort of what is the interface, what are the input properties, what are the output properties, what types do they have. So it's a bit similar to the schema you saw in Andre's presentation. For us, it's a JSON file. Yeah. Once you have that, your implementation of your component with a matching schema, yeah, you can build on one hand your provider binary, and we have all the tools for that as well. And from the schema, and it's exactly the same tooling you can use that we use for our providers, is once you have your Pulumi schema, you generate all the different language-specific SDKs. So that means that if I write my provider in Python, but you want to consume it from Node, well, you have a TypeScript library only containing the outside interface of your component. It's a request sent to the engine to create me a component. The component will resolve that to the matching provider based on the namespace. It will send it to the multi-language component plugin provider. That will send the, let's say, the expanded version of your component back to the engine, meaning, okay, you want a full network component. Well, I give you back that it needs to be a VPC, a subnet, and maybe some more. Yeah? Then the engine gets these again in and resolves each of these individual resources to its respective provider. So we just reuse that same mechanism to have the ability to create components and offer you the tools as well to make these multi-language. And that's where that code will at that moment run. I said it was a Python. Well, you can, we use a lot of different open source tools. So if you want a TypeScript implementation or a JavaScript implementation and have a single binary, well, from Vercel, we use the PKG tool, which gives you a single binary having a Node.js runtime and embedding your JavaScript code on top of that. For Python, I can't remember what exactly it was, but there is a similar tool which allows you to have a Python runtime with a Python code on top of it. Also, again, being able to build multi-platform and have it then generated different language SDKs alongside with it. So, of course, nothing without an additional demo. So here I have already a bit more extensive program, and we have code. So that means we can also give you some libraries to scrape your context. So which project am I in? Well, you don't have to repeat the name of the project. Which stack am I in? Again, you can find out which stack you're in. This is the way how you can read stack configuration. So what I set using Pulumi config set, you can read with standard libraries and find out what the region was. And from here, I'm creating a VPC. Now, there's one small difference. It's AWS X. And I mentioned, hey, in the previous small example, you saw, on the slide, you saw an AWS EC2 VPC being created. Well, the difference is that according Amazon Web Services best practices, we already built a library of some components. Yeah? And in this case, this AWS X EC2 VPC is a VPC component creating the lower level AWS VPC, subnets, routing tables, NAT gateway, the whole shebang. Once we have that set up, so all of that is set up only with this amount of code. A similar case for setting up an EKS cluster. Also, our EKS package is also an abstraction, setting up the cluster, IAM roles, node pools, all of that. And then once I have that, yeah, I'm retrieving some information out of that. So I enabled the OIDC provider for that one. I'm getting the ARN and the URL of that. I assert, this is just some TypeScript code to make sure that behind these lines, I am sure that these are no longer undefined, because OIDC provider is not, you can enable or disable it. So sometimes it returns me something, and sometimes if I don't enable it, well, it's undefined. And then I'm creating a normal AWS IAM role. And you see, in this case, I'm actually writing a JavaScript object. And yeah, if for all this code, all the properties have full type completion based on the SDKs and the typing files in all our languages. Go is just a bit more difficult because we are only now at the point where we are going to introduce Go generics, which has type T, the generic typing system, only applied now to our libraries. So once that is in place, there are a few Go casting things that you no longer need to do. So here you see a role. Then I'm gonna load a policy from this JSON file. This is one which comes from the documentation of Amazon. Create a policy with that document, attach it to the role, and then I'm creating, and in this case, so we talked about providers. Well, you can not only have the default providers which are implicitly created, but you can also set up your providers in the code. Because here I have a program where in the lines above, I am setting up the cluster, and within the same program, I'm immediately going to deploy something to it. So I'm able from this cluster component, which was a bit higher here, to retrieve the computed kubeconfig and then have a custom, an explicit provider where I immediately pass the kubeconfig from that cluster. The only thing afterwards is when I create, for example, a namespace, well, I have to pass the provider to the resource. And now I'm coming to a point where you see the full scope of every Pulumi resource. Yeah? First of all, it's the Pulumi specific name, which needs, this is the name by which we look up all the information of that resource in the state file. Yeah? So this needs to be a computable string. Then you have all the resource-specific arguments. That, yeah, the structure of this is based on which resource I want to create. But then the last part is what we call the Pulumi-specific resource options. Yeah? And setting the provider is one of these options. You can pass in an explicit provider that you just created just before that. So that means that I will create this namespace in the Kubernetes cluster with this configured by this kubeconfig, which typically contains my endpoint. So namespace, I'm creating a service account, coming back to the resource transformation in a minute. And then I'm going to deploy all of a sudden a full Helm chart. And that's something that we added to our Kubernetes provider. So the Kubernetes provider, in our case, is not only generated from the OpenAPI specs of all the standard types, but we added to that two specific things. First of all is the kubernetes.yaml.config file. So any standard Kubernetes YAML file you have with all the values specified, you can just say, okay, read the config file, and all the Kubernetes resources defined in that file will be remapped by Pulumi to have them deployed the Pulumi way. Yeah? The same thing for Helm. We embedded the whole Helm client, the Helm CLI code base in a way, in our Kubernetes provider. And without even needing the Helm CLI, I can deploy this Helm chart. Yeah? Now we have the chart resource type, and we have the release resource type. The difference is with the chart resource type, it's Pulumi who will read and interpret and sort of do an in-memory Helm template, then remap all that to Pulumi resources and deploy it that way. So that means with the chart resource, we have full insight in all the resources which are created. With the release resource, it's really a Helm release. So we only have sort of a representation of that release, but nothing more. What's the advantage or disadvantage of one of these two? Well, the chart resource, given it gives us insight in all the different resources, well, we can apply, and you see again in the last block, the Pulumi specific resource options, that we can pass transformations. One of my colleagues, and I was struggling up front with setting up the EKS cluster, and he said, you know, I found something you have in some custom resource definition, you have to remove a status field. Yeah. Well, without even patching the upstream Helm chart, I just remove it in memory from the objects constructed at Pulumi timeframe. So with the resource transformation, before it is sent to the engine, you have a callback which allows you to do anything. You get all the resource options as a key value back, also as well as the resource, as the Pulumi specific resource options, and you can fiddle with that as much as you like. Another way how people already do that, you can pass the resource transformation to one specific resource, or you can even set it as a stack, a global stack transformation. Yeah. AWS tagging, having consistent tags on taggable AWS resources, for example, is something you can define as a global stack transformation. And just you need to find out, but we have the code for that, to find what is the list of taggable resources, and then you can set your tags without needing to copy them over to every of these resources. So far, so good. Well, of course, Pulumi is great, but it doesn't offer you a way to speed up the deployment faster than Amazon can do it. So setting up a full VPC, a cluster, and having a deployment on that, that's quite tedious during this demo. So I already created one up front. And what is the running version? So to give you an insight on what was set up, yeah, this is the list, but of course a graph view is a bit better. As mentioned, the stack is always the root resource in our environment. But then you see that we have, for example, that EKS cluster component, which fans out in a whole bunch of other resources. And similar for the VPC component, which has the normal VPC of Amazon, but then subnets. Here I see an internet gateway, route tables, elastic IP addresses, NAT gateways, and routes. So all of this was set up by that single TypeScript file. Oh, and by the way, our Helm chart, for example, expanded into all of these Kubernetes resources. So far, so good. We have covered, let's say, the part of Pulumi where I talked about infrastructure as code. Now, before let's say ahead of the meetup, I had conversation with our organizing team, and I saw that there was a tweet where a poll was round on what are the topics you like to hear or have a demo about. And also, besides infrastructure and IEC tools, security and compliance was also big on the list. Yeah. Now, let that also be a part of Pulumi and also even part of our open source offering, which is policy as code. So how is that going? Well, we are also on the policy as code aspect. We also work with multiple languages. So in this case, I'm creating a policy mandating that my S3 buckets do not allow public read properties being set. Yeah, and that's why you understand now where my demo came from. So that means I'm gonna, let's say, revert for a minute this setting. So going over the policy, so this is a definition of what we call a policy pack, a whole group of policies. And then you first give it a name. And in this case, I'm going to check one AWS specific thing. You then give it a collection of policies. And the first policy I'm actually creating is this one. So to give a better indentation. So the name of the property of this policy is S3 no public read. Yeah. I can give it a description, an enforcement level, it can be advisory or mandatory. And then there is a validate resource property where you have to give a callback function on what needs to be executed to validate. And that's your implementation of that policy. Yeah. So in this case, I have a utility method validate resource of type. And I'm saying, okay, I'm going to validate an S3 bucket. And once my program finds a bucket, all the information is sent to this callback function. And if it fails, I can use this function I'm offered by the Pulumi SDK to report a violation with a certain message. So this is how you interface with our policy as code framework. So I'm going to go back to the, so although I created the bucket and I changed the property back to read, public read. So I'm going to write Pulumi up and I'm going to say, okay, policy pack is in policy TS folder. So it's still first going to run still the Pulumi program to create the bucket, but before it's going to really execute it, it's going to first send all the information to the policy pack. And in this case, you get indeed the violation that my bucket was defined with public read and it's not allowed. Yeah. So policy as code for Pulumi is open source. You can use it as you see. If you want to have these policy packs enforced, that's one of the options on our Pulumi cloud, our hosted offering. So this is a simple thing for our simple Pulumi program. Now, given code is the best way to integrate anything, we also did something else and said, okay, what about your investment in open policy agent Ringo policies? And in this case, for example, I took one and said, yeah, make sure that on my service account or that all these set of labels are applied on a resource of that type. So I'm creating all the resources via Pulumi, but I will still be applying Ringo rules, but executed by Pulumi. So I'm going to go back to my cluster and let me first check which stack do I have. This looks fine. Come on. Yeah, I'm in the running stack. So Pulumi up. And again, I'm going to pass the policy pack setting. But in this case, I'm going to use policy OPA folder. So you can sort of say to yourself that this is already the preview phase where before really executing, then also the whole policy will be verified. Yeah? And here you see, for example, that the Kubernetes policy PaC version 001 had a deny and is missing these recommended labels. Yeah? And going back to, for example, our cluster code. So somewhere at the end, I had, so here, this was the service account in the end that was verified, and the AWS LB controller SA, so it was this one. And you see there are any tags defined. So I had this. If you're already into Terraform or you have a mixed setup, well, one of the things we announced last week is that we have the ability to convert any Terraform code to any of the supported languages of Pulumi, given that the providers you use in your Terraform code exists for Pulumi as well. Yeah, because the reason for that is we fetch the schema of the providers and we remap the code. So you can use it on a Pulumi program. You can also use it on a Pulumi, you can use it on a Terraform program. You can also use it on a Terraform module. If you do it on a Terraform module, we create a component resource out of that. And with that, I thank you.
Sorry, we can continue with the questions. So, is there any questions? Ah, okay.
Okay, thank you for the talk. And I have 2 questions. So going back to the components and the multi-language support. So how does that actually work in practice? So I take my, I don't know, TypeScript. I use the generated wrapper from the, I don't know, Python component. And is there like a registration step that the component in Python needs to go to the execution engine? Or is there the identification of the component somewhere in the generated wrapper? Or how does this work exactly? So that I probably can avoid any naming conflicts.
So in the meantime, I opened one of our GitHub repos. So the AWS X package where I used the VPC component from. Well, if you go, for example, in the AWS X folder and all of this, so this is the full TypeScript code of this whole provider. Yeah. Now, the most important part is in, and I have to look where it is in this case. Okay, so here you saw in this folder, schema gen, package gen. Here you see actually the Go code to generate a JSON schema. Yeah, our engineers did a bit of magic here to read, let's say, yeah, how should I say it? This is a special case in a way that, yeah, we already had this code as a single language component. So our investment was covered here, and we created a multi-language component out of that. The problem is, of course, that from the TypeScript code, yeah, how can you extract the Pulumi schema? Well, this is actually the code that our team built from certain library to generate the Pulumi schema from starting from by going over the classes in your TypeScript library. Yeah, if I would, the thing is, I wanted to find out where the JSON version of it was, because usually it is checked in with every repository. Yeah, and once you have that JSON file, then all the rest is actually build setup, because that's all creating the platform-specific binaries. But somewhere you will see, for example, Node.js Well, it was, let me check. So the schema file was there. Yeah, here it is. So this is actually how a Pulumi schema file looks like. And then going independent what the source of source language for your provider is, once you have that schema file, yeah, then generating all these language-specific SDKs is always the same. Yeah? Whether that be for individual resources or for components. Yeah? Because the schema definition is all in that same file. You can even mix single resources with components in one provider. Yeah?
Okay, that's quite cool. And I have another question. So in Terraform, eventually, as you add more resources to the state, it becomes low, like 400 resources, and you are waiting for state refresh like 5 minutes or something like that. So that's painful. In Terraform, they came up with TerraGrant. That's quite wonky. So how do you? I assume Pulumi will eventually have the same issue, given that their interaction with state seems quite similar to Terraform. So is there like a more automated approach? I've seen that you can use like split the stack into multiple stacks and use stack references, but that seemed like basically always manually specifying, hey, that there's this stack, use that as a data source. Is there like a more automated or more convention-based stack referencing in Pulumi?
Wait, I'm gonna go back to the beginning of your question. You talked about the performance aspect of it. But with setting up an infrastructure, it depends a bit on, first of all, Pulumi tries to do as much as possible concurrently. Yeah? So if there are no dependencies between your resources, it sort of does the bulk of all the create calls all at once. And then it depends how fast your technology provider responds, of course. Once you start having relations between your resources, then of course Pulumi sequences certain the creation of certain resources, because if you and that's where those input-output dependencies come from. If I take an output from one resource in my code and I give it as an input to another resource, and typical situation is the VPC, all the rest of the network resources are to be created in a VPC. Yeah, so that means nothing else of that whole network setup can be almost nothing can be created as long as the VPC exists. So it also boils down to how many dependencies do you have between your resources. Yeah? If you organize your stacks in such a way that there are hardly any dependencies, and then use layers with separate projects and stacks, then you can get very good performance. Yeah? To give you an idea, because I work daily with our customers, there's now one customer who says it's becoming a bit slow, but they have 5,400 resources in their stack, and it's 15 minutes.
Sorry. So for my perspective, it's not no more than a minute, because if it's more than a minute, I'm going to just go brew a coffee or start doing something else, and suddenly a minute is at 15 minutes or something. And then we go to the second issue. So it's still the same state, right? So how do I get 3 people work on the same thing? Probably not with the same state, right? I will probably want them to have work on different components that's probably using different states.
It depends a bit on how you evolve your own. First of all, how is the collaboration and the technology doesn't solve everything. Yeah? That's why the whole DevOps movement started. Yeah? We have to work together. So the thing is, how do you deliver? Yeah? On a technical side for Pulumi, we use the locking mechanisms of cloud storage so that you can still use the same S3 storage or Azure object storage. if you have stacks which where I say that they have to be shared within a team. Yeah, but indeed you can balance. You have on one hand Pulumi programs, yeah, and these, when you execute them on one or more stacks, these really set up your infrastructure. And then you could, for example, you could be the author of a library creating components. Well, then you could have totally separate test stacks to test your components, which is then setting up, tearing down, setting up, tearing down. Maybe in evolution also testing that they are backwards compatible to not have a breaking way of upgrade and all that. So that could be separate from if people then use update a dependency update mechanisms like dependabot or renovate bot to say, okay, you release now a new version of your components. Well, that could be detected then by dependabot, pull request created on their stack, and so on and so on. So here as well, again, given that you use standard language packages, well, all the tooling around it, like the dependency update tracking, can be handled as well. And that's the process in the end you have to define for yourself in the company.
Yeah, but ultimately it's up to me how I split the stacks and have the people work together. But it's possible, but currently there's no automation whatsoever.
No.
Yeah, cool, thank you.
I thank you for the talk. I have kind of similar question, but maybe from a different perspective. The thing you did there, where you set up a Kubernetes cluster and then you started creating resources into it, I can tell from experience that in Terraform, if you do that, it's a very bad idea, because once you break your connection to the Kubernetes cluster, you're no longer able to manage it because it's within the same Terraform state. Does Pulumi have something that lets you ignore part of the state if the provider is broken, for example, and still manage the layer above, or do I still need to layer stacks so that they are not dependent on each other? And before you answer, the Helm feature you showed where you can have the callbacks is the biggest killer feature you have. Yeah. Okay, now you can answer. Sorry.
Of course, we are not responsible for flaky network connections. Yeah, that's one. But second, you can ignore state. You can one of the options on the Pulumi CLI is --target and --target dependence. Yeah? So if you want to run, for example, and reapply changes only to the VPC part, yeah, then you can say --target dependence. You pass the URN, which you can see in the state file or on the platform. You pass that, and then it will only focus on the VPC with its dependent resources.
Right, but so for example, let's say we are not talking about Kubernetes, we are talking about some kind of database. I set up a database, MySQL in cloud, and then I'm connecting to it. And I somehow screw up, let's say within the same, what do you call it, stacks or state, you also set up the VPC stuff and firewalls. So if you then suddenly break your VPN connection to the database, you're no longer able to access the database, and you need to edit the firewalls so that you can connect it again. And what Terraform does in this case, if you run plan, and I think even apply, and even with targets in Terraform, it still checks for the resources that are existing there, and that's broken. So do you do the same thing, or if I use your target dependency or whatever, does it actually completely ignore and doesn't check the state of the resources that should be there?
If you already want to set up resources on your database and it can't connect, it will error out at that moment.
Okay, so the same issue. Okay, thank you.
Yeah.
I have a question from another side. What is the best practice to test a large repository where is lots of infrastructure of code?
There are two mechanisms we support. First of all, given we have normal code, you have a way, and let me escape. Go back a minute to our architecture. So here is the architecture. You have your code here in the language host. Yeah, we have in our standard library a way to sort of mock this network connection. Yeah.
Maybe I will be more specific. Is there any support for writing something like test units for my providers and so on in Pulumi, or
test units?
Test units, because I'm writing a code.
Yeah.
That's my general problem with infrastructure as a code. Let's say from another languages like Terraform is how to test this code, how to write test units, and how to test it whole my infrastructure. Because let's say creating a nightly pipeline which will run everything in my testing cluster, it's good, but it doesn't help when you develop this infrastructure as code. So is there any support from Pulumi side, some API or
we have
tools?
Integration only. That is the few that the integration test framework we have is which sort of creates an ephemeral stack, lets you write tests towards what was set up at that moment, and then torn down. Yeah, that's only available in Go. Yeah, but we have support for that. So if you have an infrastructure as code program, you can complement that with that Go integration test framework and have your tests in Go to. Yeah. I talked in the beginning about the automation API. Well, that test framework under the hood uses the automation API, which means in your test code, you can sort of get the outputs, every possible thing you can do via that automation API library. You have to your availability in the code to check what are the real IDs of the resources being set up and all that. And then you can have a number of tests. And yeah, so typical test framework has a setup part, test part, tear down part. So we just hook in that lifecycle with that integration test framework.
Okay, thank you.
So any other question in the audience? If not, so I will skip to the Slido.
Just a quick question. What kind of framework do you use for the schema definition using the JSON files that you talked about? Like, is there any like JSON schema or any other, or is it custom?
It's a custom, the meta schema is written in JSON schema. Yeah, so it's a bit, the structure of a schema, a Pulumi schema, let's say, how that needs to look. We have a JSON schema for it. So if you want to write that by hand or you want to validate if it's correct, yeah, then you can. Yeah? But this is the structure of it is certain. Yeah, this is how we let's say transport the resource information over the gRPC pipes. Yeah, and that's where the meta schema comes from, because it's our gRPC schema uses the meta schema in a way to, in an abstract way, be able to transport the data for any Pulumi resource.
So question from Slido. Can I use Pulumi for managing my custom infrastructure, or it works only for clouds?
Anything that talks to an API, and then I come back to the previous talk. If there is a Terraform provider, we can sort of reuse the code of that. Yeah. So sometimes the confusion comes from that people say, yeah, but Pulumi uses Terraform under the hood. Well, what you've seen so far as our product is a totally separate product. The only thing we can do is reuse, let's say, the Terraform provider code base and remap that to have it talking our Pulumi gRPC protocol. Because in the end, it's only an adapter going from one protocol to another. Yeah? And given Terraform resources are already modeled, yeah, with the CRUD protocol, create, retrieve, update, delete, we just do the same, but using the Pulumi schema at that moment. So yes, you can, if it can talk to an API, you can model it with a provider and you can plug it in.
So next question. What can make a medium to large company choose Pulumi over Terraform or CloudFormation?
A number of things. The testability, so unit test framework, integration test framework. Larger companies usually with different teams working with different programming languages. So with the programming language, we come even closer to each team's knowledge already. Yeah? So that means that, for example, more of an ops team can build the components, and a front-end team can consume it in TypeScript. Yeah? If you have a data science team, which typically is more Python-oriented, well, you can consume the same components in Python. So, and it's that interaction. On top of that, what we see is that once people started using Pulumi and then they find out about Pulumi Automation API, well, that's talking about killer features. That's for our biggest customers, that's the killing feature, yeah? That they can just embed Pulumi in their bigger setup.
Okay, thanks. The next one I think was already answered. It was about managing the same project with more people. So we will skip to the last one. Having multiple languages supported requires having interpreter for each language available. Doesn't that fact override the necessity of learning a new language?
I'm not sure that if I understand that question. So having more than one language requires...
I can repeat it if you want.
Yeah, if you want.
Having multiple languages supported requires having interpreter for each language available. Doesn't that fact override the necessity of learning a new language? Maybe if the...
Well,
maybe?
In a way, you don't have to learn them all. It's just that given we have that whole set, if you're more versed in the whole .NET ecosystem, well, you can also write your infrastructure code in .NET. If you're more of a Java ecosystem, we also support Java. And yeah, so we just, with the support for all the different languages, we actually try to come closer to where you are already. Yeah? And hereby preventing the need to learn another language.
I have a follow-up question for that. So there's like 6 or 7 languages or maybe more supported, but from what I've seen, TypeScript is the one truly supported and everything else is like a bit less supported, or the experience there kind of sucks some of the time. So when we evaluated Pulumi some time ago, it was either everybody in operations learns TypeScript or we don't adopt it at all. That's one side. The other was that if you actually decide to adopt it because it supports like multitude of languages, and you have huge organizations with like hundreds or thousands of people and different teams. So, and each team decides to use Pulumi in different language. Doesn't that end up in a huge mess kind of situation where you try to like, hey, this whole stack doesn't work for me, and then you go from one component to other component, and you try to figure out what the hell is broken, and each time you turn to another component, it's in completely different language. So you either end up with like 6 people in the room, each knowing his own language, or a unicorn of a person who knows them all. So do you have any stories regarding like how well this works in practice?
Unfortunately, I can't name names of our customers, but we have customers who work with Pulumi, and where the starting Pulumi team was already around 75 people, and they started to serve about 30 different teams within the organization, and it started spreading. So they did internal trainings, and eventually it all boils down. What do you typically see in very big companies? Yeah, you get some standardization. Yeah, it's not everybody can really freely choose. Yeah, so in the end, you sometimes see that it boils down to 2 languages, real programming languages. But don't forget, if you have components, you can even, without even writing any code, you can even put the program in the Pulumi YAML file in YAML. Yeah, so if you want to instantiate a component, you just add a YAML section to your Pulumi YAML project descriptor, which is a valid Pulumi YAML project at that moment. So even if you just want to quickly instantiate a component, you can fall back to that. So that's what we typically see. 1 or 2 major languages being used in the company, and then maybe some instantiating of components the YAML way. Yeah, and for the rest, it boils down, it's code, so it all boils down to the same characteristics of code quality, testing, versioning, lifecycle.
So, okay, last question.
Yeah, thank you. It was an interesting feature of the auto naming, and so do I understand correctly that the part that is generated automatically goes to every resource? I just have a bit of a problem that some cloud APIs have like very limited number of characters I can put there, and I want to enforce some sort of naming convention. I sometimes end up with 5 characters left for imagination, and if Pulumi takes these 5 characters, I would be very unhappy. So I wonder how much is this configurable, this auto naming feature?
It is configurable per resource. If you, that's why I went over the structure of a resource. You had the Pulumi specific resource name in the beginning. That's how we look up the state corresponding to the resource. Then you have the resource specific arguments. And if you then pull up the documentation, every resource somewhere has more of a name property. S3, for example, it's called bucket. But any more readable name property is sort of that name that we use for auto naming. Yeah. If you use the same name as the first argument, also as the name input property, then you're at that moment overriding the auto naming. Done.